Welcome to lesson 6.1, Basics of Chemical Equations, Part 1. So as always, please make sure to title your notes what it says in red next to the title here. And by the end of the video, these are the 4 things you need to know. So today we started on Unit 6, which is all about how medications are made. So there are 3 key things that we're going to talk about, and we're starting with how a chemical equation works. And in our Zoom class today, we looked at a sandwich recipe, and it's essentially the same method of how a chemical equation works, right? Except in chemistry, it just looks a little something like this, right? And what we're actually doing is we're just mixing herbs and plants together in order to make some sort of substance we want to create. So in this case, if you mix wintergreen oil with willow bark, specifically white willow bark, you can make a tea that contains aspirin, right? So a chemical equation in chemistry is something that looks like this. And essentially, what it is a way of writing a chemical reaction. Or how I like to think about it is it's basically a recipe for how to make something in chemistry, right? So I would definitely write down this definition for a chemical equation and also this particular example. So you'll notice that in a chemical equation, just like a recipe, you have different parts. Right, so the first part, the part before the arrow, is what we call our reactants. And they're essentially substances or ingredients used to mix together in order to create the reaction. So anything before this arrow that's drawn here, in this case, the two H2s and the one O2 molecule are our reactants. And if I were to draw this out, right, essentially what I have here, I have two H2s, and I have one O2. These are my reactants. But instead of drawing them each time, it's much faster just to write it out as a chemical equation. So I would definitely write down the definition of reactants and kind of circle them in the same color in your example in your notes as well. For your products, this is essentially what you can make with your ingredients or your reactants, right? So therefore, your products are always shown after the arrow. And these two are your products. So if you combine two H2s and one O2, you're going to end up with two H2O. So again, just think of a chemical equation as a recipe in chemistry. The reactants are like your ingredients, circled here in purple, and the products are just what you make. So another part of the chemical equation that you need to know is what the arrow represents and what the plus sign before the arrow represents. So before the arrow, if you see a plus sign, that means you're combining these two things together, right? And when these two things combine, something will happen. And the arrow just means that you're going to make this thing, right? It's pretty straightforward, but I just wanted to make that clear. Sometimes after the arrow, you'll find that it'll make two things. So maybe if you combine two H2s and one O2, it's going to yield or produce not only two molecules of H2O, but also something else, right? So if you see a plus sign after the arrow, it doesn't mean that these two things are going to combine together, but you're just going to make this thing and something else. Additionally, sometimes at the end of the molecule, you'll also see kind of these italicized symbols here. So an italicized G in parentheses, G, and then a lowercase l. So all this means is that it tells you the phase of this molecule, right? So if you see S, that stands for solid, G is for gas, L is for liquid, AQ is the trickiest one. AQ stands for aqueous in Latin, pronounced aqueous. And that basically just means it's something in water. So it's going to mix in with water. I would definitely write down these symbols in red and have an example like this where you circle the symbols in the same color so you know what they mean. This part here is pretty straightforward, so I would only write this down if this was confusing for you. And just as a side note, if you think about ingredients and things you make, right? Sometimes you have liquid butter in your recipe, and sometimes you want to use solid butter in your recipe. This is just a shorthand or quick way of letting the chemist or individual know what phase, whether it be solid, liquid, gas, or aqueous, should their ingredients or reactants be, and what phase will they produce something in. So let's try one practice example together. I have 3 questions here and one chemical equation. So question number 1 asks, identify the reactants and the products. So recall that your reactants are essentially everything before the arrow, right? So what molecules do I have before the arrow? Well, it's going to be Na and Cl2, right? This number 2 just means I have 2 of these Na things. And if there's no number in front, that just means I have 1 of them. So my reactants are going to be Na and Cl2. Don't really need to write the amounts of which one I have, nor do I really need to write their phases unless I ask for them. In terms of the products, those are things after the arrow, right? So after the arrow, I make 2 of these things called NaCl, and they're going to be solid. So I'm going to make NaCl. That's what I'm going to produce. Question number 2 asks, identify the phase of the molecules. So let me write out each molecule first, and then their phases. Okay, so I have the same 3 molecules written out on here. And when we're talking about the phases, we're trying to figure out whether they're solid, liquid, or gas, right? So to figure that out for Na, I'm just going to check at the end of Na what's in parentheses and italicized. It's G. So G stands for gas. You can always double check your notes from the previous slide about that. Cl2, at the end of Cl2, it's also G, so this is also going to be gas. NaCl, at the end of NaCl, in parentheses, it says S. And if I check my notes, S stands for solid. Right? So that's how I identify phases of each molecule. So question number 3 asks, identify how many products can be made using the original chemical equation, right? So the key thing that it's asking here is how many products. So if I'm looking for the amount of things, I need to look at the number in front, which we'll talk about in the next lesson in more detail. So because we're talking about products, remember NaCl after our arrow is our product. How many NaCl's can you make? Well, in front of the NaCl is 2. So therefore 2 NaCl can be made. And that's pretty much it for lesson 6.1.